Hello and welcome to your ultimate guide for the C458 OA Health, Fitness and Wellness course. My goal today is simple: give you everything you need to fully understand the key concepts, master them, and walk into your C458 OA exam with total confidence. In this video we'll cover skeletal system, muscular system, nervous system, body systems and principles of fitness. And remember, our website offers free exam guides and practice questions to help you ace your C458 OA exam. You'll find the link in the description below, so be sure to check it out and get the resources you need to study smarter, not harder. So let's dive right in. Let's begin by building the human body from the ground up, starting with the skeletal system. Think of the skeletal system as the internal framework, the scaffolding that allows us to stand, move and protect our vital organs. Humans are vertebrates, which simply means we have a backbone or vertebral column called the spine. This system, which includes all our bones, cartilage, ligaments and tendons, makes up about 20% of our body weight. The adult human skeleton is a masterpiece of engineering, typically composed of 206 bones, each with a specific shape for a specific job. For your C458 OA exam, you'll want to be familiar with the four main classifications of bones. First, we have long bones. As the name suggests, these bones are longer than they are wide. Their main function is to act as levers for movement. Think about the major bones in your limbs: the femur in your upper leg, the humerus in your upper arm, and the radius and ulna in your forearm. When muscles pull on these bones, they create large, sweeping motions. Second are short bones. These are roughly cube-shaped, about as long as they are wide. You find them in places requiring fine, gliding movements, like your wrists, where they're called carpals, and your ankles, where they're called tarsals. They provide support and stability with little movement. Third, we have flat bones. These are thin, flattened, and often a bit curved. Their job is primarily protection for vital organs and providing a large surface area for muscles to attach to. The best examples are the bones of the skull that protect your brain, your sternum or breastbone that protects your heart, and your scapula or shoulder blade. Finally, there are irregular bones. These are bones with complex shapes that don't fit into the other categories. Their unique shapes are suited for their specific functions. The vertebrae of your spine are a perfect example. Their odd shape allows them to protect the spinal cord, while also permitting flexibility. The pelvic bones are another example of irregular bones. Now, a skeleton would just be a pile of bones without joints, the places where two or more bones meet. Joints, also called articulations, are what give our skeleton mobility. They are classified by their degree of movement, and this is a key concept. First, there are immovable joints, also called fibrous joints. The bones here are fused together and permit no movement at all. The sutures in your skull are the classic example. They start as separate plates in infancy, but fuse together to form a solid, protective case for the brain. Second, we have slightly movable joints. Here the bones are connected by cartilage, allowing for a small amount of movement. The joints between your vertebrae, cushioned by intervertebral discs, are a great example, as is the pubic symphysis, which connects the two halves of your pelvis. The third and most complex category is freely movable joints, or synovial joints. These are the joints you probably think of most often: knee, elbow, shoulder, hip. They allow for a wide range of motion and have a special structure, including a capsule containing lubricating synovial fluid, which is why they're called synovial joints. For the C458 OA exam questions, it's helpful to know the different types of these synovial joints. There are ball and socket joints, like your shoulder and hip, which allow for the greatest range of motion in all directions. There are hinge joints like your elbow and knee, which work like a door hinge, allowing for movement in only one direction. Bending and straightening. Pivot joints allow for rotation, like the joint in your neck that lets you turn your head from side to side. And there are saddle joints, like the one at the base of your thumb, that allow for back and forth and side to side movement, but not full rotation. But bones and joints can't function in isolation. They rely on critical connective tissues. Let's get these crystal clear. First is cartilage, the tough but flexible tissue that acts as a shock absorber. It covers the ends of bones in synovial joints, creating a smooth gliding surface. Imagine it as the Teflon coating on a frying pan, preventing things from sticking and scraping. A torn meniscus in the knee is a common cartilage injury. Next, we have ligaments. A great way to remember this is that ligaments link bone to bone. They are like strong, slightly elastic bands of duct tape that hold your skeleton together and provide stability, preventing joints from moving in the wrong direction. A sprained ankle is an injury to ligaments, and a torn ACL in the knee is a severe ligament injury. Finally, we have tendons. Remember this, tendons tie muscle to bone. They are tough, non-elastic cords that transmit the force from a muscle contraction to the bone, causing it to move. The Achilles tendon, connecting your calf muscle to your heel, is the largest tendon in your body. When you get tendinitis, it's an inflammation of one of these tendons. One last crucial point. Cartilage and ligaments have a very poor blood supply, which is why injuries to them, like a torn ACL or cartilage damage, heal so slowly or sometimes require surgery. Bones, on the other hand, have a rich blood supply and heal much more quickly. Before we move on to the muscular system, I want to let you know about something that's going to be incredibly valuable for your exam preparation. I've created over 300 completely free practice questions that work hand in hand with everything we're covering in this comprehensive guide. You'll find the link in the description, and I really encourage you to bookmark it because these questions will help you apply every concept we discussed today. Now that we have the framework, let's power it with the muscular system. Muscles are the engines of the body, responsible for all movement. But their job goes beyond just moving bones. They help us maintain posture against gravity, stabilize our joints by keeping tension on the tendons, and even produce heat through shivering when we're cold. For your exam, you need to know the 3 types of muscle tissue inside and out. First and most familiar is striated muscle, which is also called skeletal muscle. This is the muscle under your conscious, voluntary control. When you decide to kick a ball, pick up a book, or smile for a photo, you're using your skeletal muscles. They attach to the skeleton, usually via tendons, and work in pairs. For instance, to bend your elbow, your bicep muscle contracts. This is the agonist. While your tricep muscle relaxes. This is the antagonist. To straighten your elbow, the roles reverse. The term striated comes from the fact that under a microscope, the muscle fibers have a striped appearance. The second type is smooth muscle, also known as visceral muscle. You do not have voluntary control over this type of muscle. It works automatically. It's found in the walls of your internal or visceral organs. For example, smooth muscle in the walls of your intestines contracts in a wave-like motion called peristalsis to move food along. Smooth muscle in the walls of your arteries and veins contracts and relaxes to control your blood pressure and blood flow. Even the tiny muscles in your eyes that change the size of your pupils are smooth muscles. It is tireless and works 24/7 without you ever thinking about it. The third type is cardiac muscle, and it is found in only one place in the entire body, the heart. Cardiac muscle is a fascinating hybrid. Structurally, it is striated like skeletal muscle, which gives it the power to pump blood forcefully throughout the body. However, functionally, it is involuntary, like smooth muscle. You don't have to tell your heart to beat. It has its own internal pacemaker that keeps it beating rhythmically. Cardiac muscle cells are joined by special connections called intercalated discs, which allow electrical signals to pass rapidly from one cell to the next, ensuring the entire heart contracts in a coordinated, powerful wave. So to summarise for any C458 OA exam questions on this topic, skeletal muscle moves the skeleton and is voluntary. Smooth muscle is in internal organs and is involuntary. Cardiac muscle is only in the heart, is striated for power, and is involuntary. So we have the structure and the engine. What about the control centre? That's the nervous system. Think of it as the body's incredibly complex electrical wiring, and central computer combined with a sophisticated data network. It is the master controlling and communicating system of the body, and its complexity is astounding. Every thought, every action, every sensation is managed by the nervous system. The nervous system is divided into two major parts. The first is the central nervous system, or CNS. This is the command center. It consists of the brain and the spinal cord. The brain is the main processor, where information is interpreted, decisions are made, and memories are stored. The spinal cord is the main data cable, a superhighway for nerve impulses travelling between the brain and the rest of the body. The second division is the peripheral nervous system, or PNS. Peripheral means on the edge or outer part, and that's a perfect description. The PNS is made up of all the nerves that branch out from the brain and spinal cord, extending to all other parts of the body, including your limbs, face, and organs. Its job is to be the communication network. It has two key functions. First, it sends sensory information from the body to the CNS. For example, nerves in your skin tell your brain that the water in the shower is hot. Second, it carries motor commands from the CNS out to the body's muscles and glands. After your brain processes that the water is hot, it sends a command via the PNS to the muscles in your hand to turn the faucet. Let's dig a little deeper into the PNS, as this detail is often tested. The PNS itself is divided into two parts. The somatic nervous system controls voluntary movements of skeletal muscles. When you decide to walk, you're using your somatic system. The autonomic nervous system regulates all the automatic, involuntary functions like your heartbeat, breathing, and digestion. Autonomic sounds like automatic, which is a great memory aid. But we can go even one level deeper. The autonomic nervous system is further divided into two opposing branches. The sympathetic division is your fight or flight system. It prepares your body for intense physical activity. Imagine you're being chased by a dog. Your sympathetic system kicks in. Your heart rate skyrockets. Your breathing becomes rapid. Your pupils dilate. And adrenaline is pumped into your bloodstream. It gets you ready for action. Its counterpart is the parasympathetic division, your rest and digest system. It calms the body down and directs routine activities. After you've escaped the dog and are resting safely, your parasympathetic system takes over, slowing your heart rate and stimulating digestion. These two systems work in a delicate balance to keep your body in a stable state. Next, let's explore how the body gets the fuel and oxygen it needs to every one of its trillions of cells. This requires the perfectly coordinated teamwork of the respiratory and cardiovascular systems. Let's begin with the respiratory system. Its primary function is respiration, which is more than just breathing. It's the entire process of getting oxygen from the air into your blood and removing the waste gas, carbon dioxide, from your blood into the air. This happens without you even thinking about it, around 20,000 times a day. The pathway of air is crucial. Air enters through your nose or mouth where it is warmed and humidified. It then travels down your pharynx, throat, past your larynx, voice box, and into your trachea, windpipe. The trachea then splits into two main branches called bronchi, one for each lung. These bronchi continue to branch into smaller and smaller tubes, like the branches of a tree, in a network called the bronchial tree. At the very end of the tiniest branches are millions of microscopic air sacs called the alveoli. This is the site of gas exchange. Imagine the alveoli as tiny balloons with incredibly thin walls, and each one is wrapped in a dense web of tiny blood vessels called capillaries. Here, oxygen easily diffuses from the high concentration environment of the alveoli into the low concentration blood in the capillaries. At the same time, carbon dioxide, which is a waste product from your body's cells, diffuses from the blood into the alveoli to be exhaled. This is the perfect handoff to the cardiovascular system, which is the body's transportation network. Its job is to pick up that oxygen and deliver it along with nutrients everywhere it's needed. The system consists of the heart, a four-chambered muscular pump, and a vast network of blood vessels. Let's trace the full journey of a single red blood cell, which is a very common topic on the C458 OA exam. Let's start with oxygen poor blood returning from the body. It enters the right atrium, the top right chamber of the heart. The right atrium contracts and pushes the blood through the tricuspid valve into the right ventricle, the bottom right chamber. The powerful right ventricle then contracts and pumps this oxygen-poor blood through the pulmonary valve and into the pulmonary artery, which leads to the lungs. In the lungs, at the alveoli we just talked about, the blood drops off its carbon dioxide and picks up a fresh load of oxygen. Now bright red and oxygen-rich, the blood travels back to the heart, through the pulmonary veins and enters the left atrium, the top left chamber. The left atrium contracts, pushing the blood through the mitral valve into the left ventricle. The left ventricle is the strongest chamber of the heart because it has to pump blood to the entire body. It contracts with immense force, sending the oxygen-rich blood through the aortic valve and into the aorta, the body's largest artery. From the aorta, the blood travels through a branching network of smaller arteries, eventually reaching the capillaries, where it delivers oxygen and nutrients to the cells. The now oxygen-poor blood then begins its journey back to the heart through the veins, and the entire cycle starts over. A key takeaway is the separation of the two circuits. The pulmonary circuit goes to and from the lungs, and the systemic circuit goes to and from the rest of the body. And remember, arteries carry blood away from the heart. Veins carry it back to the heart. So we've covered how the body gets oxygen, but what about nutrients from the food we eat? That's the domain of the digestive system. Its mission is to break down the food we eat into molecules small enough to be absorbed into the bloodstream and utilised by our cells. This process involves four main functions: ingestion, eating; digestion, breaking down; absorption, taking in nutrients; and elimination, getting rid of waste. The digestive tract is essentially a long muscular tube that runs from the mouth to the anus. Let's follow the journey of a bite of a sandwich. Ingestion happens in the mouth. Here, two types of digestion begin. Mechanical digestion happens as your teeth cut and grind the food. Chemical digestion starts as an enzyme in your saliva called salivary amylase begins breaking down carbohydrates. Once swallowed, the food, now called a bolus, travels down the esophagus, propelled by the wave-like muscle contractions of peristalsis. It then enters the stomach. The stomach is a J-shaped organ that acts as a muscular mixing bowl. It continues mechanical digestion by churning the food, and it performs major chemical digestion. The stomach secretes hydrochloric acid, creating a highly acidic environment that kills most bacteria, and an enzyme called pepsin, which begins the digestion of proteins. This soupy mixture is now called chyme. From the stomach, the chyme is slowly released into the small intestine. The small intestine, despite its name, is very long, about 20 feet, and is where most digestion and virtually all absorption occurs. Its surface is lined with millions of tiny, finger-like projections called villi, which themselves are covered in even tinier projections called microvilli. This structure massively increases the surface area for absorption. The digestive system also has critical accessory organs that help this process. The liver, a large organ, produces bile, which is stored in the gallbladder. Bile is not an enzyme, it's an emulsifier. It works like dish soap on grease, breaking down large fat globules into smaller droplets that enzymes can then attack. The pancreas secretes a cocktail of powerful digestive enzymes that break down carbohydrates, fats, and proteins. The pancreas also produces the hormone insulin, which is crucial for regulating blood sugar. After the small intestine has absorbed all the nutrients, the remaining indigestible material, mostly water and fibre, passes into the large intestine. The main job of the large intestine is to absorb the remaining water, electrolytes, and vitamins produced by gut bacteria, and to compact the waste into solid feces, which is then eliminated. After digestion and metabolism, the body has waste products circulating in the blood that could become toxic if they accumulated. Removing these wastes is the primary job of the urinary system, also called the renal system. Its main goals are to filter waste from the blood, maintain the body's delicate balance of fluids and electrolytes, and regulate blood pressure. The stars of this system are the two kidneys, which are bean-shaped organs located on either side of the spine just below the rib cage. Each kidney contains about 1 million microscopic filtering units called nephrons. This is where the real work is done. The process in the nephron is a 3-step marvel. First is filtration. Blood enters the nephron under high pressure, and everything small, water, salts, glucose, amino acids, and waste products like urea, is forced out of the blood and into a collecting tubule. Large things like blood cells and proteins stay behind. It's like dumping the entire contents of your grocery bag onto the counter. The second step is reabsorption. As this filtered fluid moves along the tubule, the body reclaims everything it needs. Essential substances like glucose, amino acids, and most of the water and salts are actively transported back into the blood. This is like putting your apples, milk, and bread back into the bag. The final step is secretion. This is the last chance to get rid of waste. The body actively pumps any remaining waste products, like excess drugs or hydrogen ions, from the blood into the tubule. This is like finding a piece of trash in your pocket and throwing it into the waste pile. The fluid that remains at the end of this process is urine. The urine flows from the kidneys down 2 thin tubes called the ureters to the bladder. The bladder is a muscular sac that stores the urine. When it's full, it stretches, sending a signal to the brain. Finally, urine is expelled from the body through a tube called the urethra. What we just covered about the digestive and urinary systems is exactly the type of detailed process you'll find in our free practice question bank. These aren't just basic questions either. They're designed to test your deep understanding of how these systems work, just like the real OA exam will. Now let's talk about the body's defense systems. How does it protect itself from the constant threat of pathogens like bacteria and viruses? This is the job of 2 key systems working in tandem, the immune system and the integumentary system. The immune system is the body's internal army, a complex network of cells, tissues, and organs that work together to identify and destroy foreign invaders. The primary soldiers of this army are the white blood cells, or leukocytes. There are many types, each with a specialized role. They're constantly patrolling your bloodstream and tissues. These invaders, or pathogens, have unique molecules on their surfaces called antigens, which act like enemy flags. When your immune cells recognize an antigen as foreign, they launch an attack. This brings us to a crucial distinction for your C458 OA exam: the difference between innate and adaptive immunity. Innate immunity is your non-specific, first-line defense. You're born with it. It includes physical barriers like your skin, chemical barriers like stomach acid, and general attack cells that destroy any invader they see. The inflammatory response, swelling, redness, heat and pain, is part of innate immunity. It's a general call to arms rushing blood and immune cells to the site of an injury or infection. Adaptive immunity, on the other hand, is highly specific, and it learns. When you are exposed to a new pathogen, your adaptive immune system creates cells, like B cells and T cells, that are specifically designed to fight that one pathogen. B cells produce antibodies, which are like smart bombs that lock onto a specific antigen. Crucially, the adaptive immune system has memory. After it defeats a pathogen, it leaves behind memory cells. If that same pathogen ever tries to invade again, these memory cells launch a much faster and stronger attack, often wiping out the invader before you even feel sick. This is the principle behind vaccines. A vaccine introduces a safe, weakened, or dead version of a pathogen, or just its antigen, allowing your adaptive immune system to build up memory cells without you having to get sick first. The body's very first line of defense, however, is the integumentary system. This is the technical term for your skin, hair, and nails. Integumentary literally means covering. Your skin is your largest organ and an incredible multifunctional barrier. Its most obvious function is to provide a physical wall between your internal organs and the outside world, preventing bacteria and viruses from getting in. It's also waterproof, preventing you from losing too much water and becoming dehydrated. The skin is packed with nerve endings that provide your brain with constant information about temperature, pressure, and pain. It plays a vital role in temperature regulation. When you're hot, blood vessels in the skin dilate to release heat, and sweat glands produce sweat, which cools you down as it evaporates. When you're cold, the blood vessels constrict to conserve heat. Your skin also contains sebaceous glands that produce an oily substance called sebum. Sebum helps to waterproof the skin and keep it lubricated and soft. Hair provides insulation and protection, while nails made of a hard protein called keratin protect the sensitive tips of your fingers and toes. So you can think of the integumentary system as the fortress walls and the immune system as the army inside. Let's shift gears from the body structure and function to the principles of maintaining it: health, wellness, and fitness. A huge part of your C458 OA exam will be on the practical application of fitness principles. Let's start with the 5 components of physical fitness. Understanding each one is essential. The first is cardiorespiratory fitness. This is the ability of your heart, lungs, and blood vessels to efficiently deliver oxygenated blood to your working muscles during sustained physical activity. It's about how long you can keep going. Think of running a 5K, swimming laps, or cycling for an hour. Someone with good cardiorespiratory fitness can do these activities with less effort and for a longer time. The second is muscular strength. This is the absolute maximum amount of force a muscle or muscle group can generate in a single, all-out effort. It's about raw power. Examples include performing a 1 repetition max on a bench press or squat, or lifting a very heavy box. In daily life, it's the strength you need to carry a heavy suitcase up a flight of stairs. The third is muscular endurance. This is different from strength. It's the ability of a muscle or muscle group to repeatedly exert force or to hold a contraction for a prolonged period. It's about stamina. Examples include doing 30 push-ups in a row, holding a plank for 2 minutes, or raking leaves in the yard for an hour. While strength is about one big effort, endurance is about many smaller efforts over time. The fourth component is flexibility. This is the ability of your joints to move through their full, unrestricted, pain-free range of motion. It's not just about being able to touch your toes, it's about having the mobility to perform daily tasks easily and without injury, like bending down to tie your shoes or reaching for something on a high shelf. Activities like stretching, yoga, and Pilates are excellent for improving flexibility. Finally, the fifth component is body composition. This refers to the relative proportions of fat mass and fat-free mass in your body. Fat-free mass includes your muscles, bones, water, and organs. A healthy body composition is one that has a lower percentage of body fat and a higher percentage of fat-free mass. This is important because excess body fat is linked to a higher risk of many chronic diseases. To improve these 5 components, we use the FIT principle. This is a crucial mnemonic you must know for your exam. FITT. F stands for frequency, which is how often you exercise. For example, you might engage in cardiorespiratory activity 5 days per week. I stands for intensity, which is how hard you exercise. This can be measured as low, moderate, or vigorous, often in relation to your heart rate. T stands for time, which is the duration of your exercise session, for example, 30 minutes. And the final T stands for type, which is the specific kind of exercise you are doing. Let's create a simple, well-rounded weekly plan for a beginner using FIT. For cardiorespiratory fitness, the plan might be frequency 3, 4 days a week. Intensity, moderate, where you can still hold a conversation. Time, 30 minutes. Type, brisk walking or cycling. For muscular strength and endurance, it could be frequency, 2 days a week, not on consecutive days to allow for muscle recovery. Intensity, lift a weight that you can manage for 8 to 10, 12 repetitions. Time, 2, 3 sets of 8, 12 reps per exercise. Type, using free weights, resistance bands, or bodyweight exercises like squats and push-ups for flexibility. Frequency 5, 7 days a week. Intensity, stretch to the point of mild tension, not pain. Time, hold each stretch for 15, 30 seconds. Type, static stretching after your workout. A key part of the intensity in the FIT principle is understanding and using your target heart rate. This is a practical calculation you may be asked about on the C458 OA exam. To find your target heart rate zone, you first need to estimate your maximum heart rate, or MHR. The most common and simple formula is 220 minus your age. Let's use a 30-year-old as an example. Their MHR would be 220 minus 30, which is 190 beats per minute, BPM. This is the absolute fastest their heart should safely beat. Now, a moderate intensity workout is typically defined as 50% to 70% of your MHR. So for our 30-year-old, we calculate 50% of 190, which is 95 BPM, and 70% of 190, which is 133 BPM. So their moderate target heart rate zone is between 95 and 133 beats per minute. Vigorous intensity exercise is 70% to 85% of MHR. For our 30-year-old, that would be between 133 and 162 BPM. By using a heart rate monitor or by taking your pulse, you can ensure you're in the right zone to maximize the benefits of your workout safely. A simpler, more subjective way to gauge this is the talk test. During moderate activity, you should be able to talk but not sing. During vigorous activity, you won't be able to say more than a few words without pausing for breath. I know we're covering a lot of detailed information, and you might be wondering how to practice applying all these concepts. That's precisely why I put together those 300 plus free practice questions I mentioned earlier. They'll help you work through problems that combine multiple concepts, just like you'll see on the actual exam. Now let's discuss health and disease. Diseases can be broadly categorized as infectious or chronic. Infectious diseases are caused by germs or pathogens and can often be transmitted from one person to another. It's crucial to know the four main types of germs. First are bacteria, which are single-celled organisms that are everywhere. Most are harmless, but some cause diseases like strep throat or bacterial pneumonia. These can often be treated with antibiotics. Second are viruses, which are even smaller than bacteria. They're not technically alive on their own. They need to invade a host cell to replicate. Viruses cause illnesses like the common cold, the flu, and chickenpox. Antibiotics do not work on viruses. Third are fungi, which are primitive plant-like organisms. Examples include the fungus that causes athlete's foot or yeast infections. Fourth are parasites, which are organisms that live on or in a host and get their food from or at the expense of that host. Examples include the parasite that causes malaria or the tiny mites that cause lice. These germs can be transmitted in several ways, through direct contact like kissing or a sneeze droplet, through indirect contact like touching a doorknob that a sick person touched, through bites from insects like mosquitoes or ticks, or through the consumption of contaminated food or water. Chronic diseases, on the other hand, are long-lasting conditions that are generally not caused by germs and are not contagious. They are the leading causes of death and disability worldwide. Your C458 OA exam will expect you to be familiar with the major ones. Cardiovascular disease is an umbrella term for conditions affecting the heart and blood vessels. The most common form is coronary artery disease, or CAD. This is caused by a process called atherosclerosis, which is the buildup of cholesterol-laden plaque inside the arteries, narrowing them and restricting blood flow. If a piece of this plaque ruptures, a blood clot can form and completely block the artery, leading to a heart attack. A stroke is what happens when the blood supply to part of the brain is cut off, causing brain cells to die. Hypertension or high blood pressure is a major risk factor for both heart attacks and strokes because it puts extra strain on the heart and damages artery walls, accelerating atherosclerosis. Cancer is another major chronic disease. It is not one disease, but a collection of related diseases characterized by the uncontrolled division of abnormal cells. These cells can form masses called tumours. A benign tumour is not cancerous and does not spread. A malignant tumour is cancerous. Its cells can invade nearby tissues and spread to other parts of the body through a process called metastasis. Diabetes, specifically type 2 diabetes, is a very common chronic condition. It occurs when the body either doesn't produce enough insulin or the body's cells become resistant to insulin's effects. Insulin is the hormone that helps move sugar or glucose from your blood into your cells to be used for energy. Without it working properly, sugar builds up in the blood, which can damage organs over time. Risk factors for these chronic diseases often include a mix of non-modifiable factors like age and genetics, and modifiable factors like diet, physical activity, and smoking. As we wrap up this detailed overview, remember that understanding these concepts is just the first step. The real mastery comes from applying them, which is where those 300+ free practice questions become invaluable. They're completely free and designed specifically for OA exam success. Finally, let's bring it all home with personal hygiene and safety. These practical topics are essential for day-to-day health and are likely to appear as application-based questions on your exam. Good personal hygiene is the foundation of preventing the spread of infectious diseases. The single most important habit is effective hand washing. This means using soap and water and scrubbing for at least 20 seconds, about the time it takes to sing Happy Birthday twice. The friction from scrubbing and the properties of soap work together to lift and remove germs. You should always wash your hands after using the restroom, before preparing or eating food, after coughing, sneezing, or blowing your nose, and after touching animals. Dental hygiene is also critical. Brushing twice a day with a fluoride toothpaste removes plaque, a sticky film of bacteria, and fluoride helps to strengthen tooth enamel. Flossing once a day is essential to remove plaque from between the teeth where a toothbrush can't reach. Unintentional injuries are another major public health issue. Drowning is a silent and quick killer, especially for young children. The key prevention strategies are layers of protection, learning life-saving skills like swimming and CPR, installing four-sided fencing around backyard pools, consistently using US Coast Guard approved life jackets in and around natural bodies of water, and most importantly, providing close, constant, and attentive supervision to children near any water. Poisoning is another preventable tragedy. The key is to store all medications, cleaning supplies, and toxic products in their original containers and in cabinets that are locked or out of reach of children. It's also vital to have the Poison Control Centre's phone number programmed into your phone and posted in your home. Fire safety is another critical area. Every home must have working smoke alarms on every level and inside each sleeping area. They should be tested monthly. Every family needs to create and practice a home fire escape plan, with 2 ways out of every room and a designated meeting spot outside. This practice is crucial because in the smoke and panic of a real fire, you will fall back on what you have rehearsed. Lastly, let's talk about responding to injuries. For minor cuts and scrapes, the procedure is to first stop the bleeding by applying firm, gentle pressure with a clean cloth or gauze. Then clean the wound by rinsing it with cool water. Applying an antibiotic, ointment, and covering it with a sterile bandage can help prevent infection. For more serious medical emergencies, like if someone collapses and is not breathing, knowing CPR can be the difference between life and death. Cardiopulmonary resuscitation, or CPR, is a technique used to manually pump blood to the brain and other vital organs when the heart has stopped. Hands-only CPR, which focuses on fast and deep chest compressions in the centre of the chest, is recommended for use by the general public on adults and teens who suddenly collapse. It's a skill everyone should learn. We have covered an immense amount of material today, journeying from the microscopic workings of our cells all the way to creating a weekly fitness plan. We dissected the body system by system, the skeletal and muscular systems providing our form and movement, the nervous system as our master controller, the respiratory and cardiovascular systems as our delivery network, the digestive and urinary systems for processing fuel and waste, and the immune and integumentary systems as our great protectors. We then applied this knowledge to the principles of health and fitness, defining the 5 key components and using the FIT principle to build a plan. We explored the critical differences between infectious and chronic diseases, and we concluded with the practical life-saving skills of hygiene and safety. The most important thing I want you to take away is that these topics are not isolated facts to be memorized. They are deeply interconnected. Your diet directly impacts your cardiovascular health and body composition. Your level of physical activity influences your muscular strength, bone density, and even your immune function. Your hygiene habits are your first line of defence against infectious disease. As you study for your C458 OA exam, focus on making these connections. Ask yourself how and why. How does smoking affect the respiratory system and the cardiovascular system? Why is flexibility important for preventing injuries in the muscular and skeletal systems? When you start thinking in this integrated way, you're not just studying for an exam, you're truly understanding the magnificent, complex machine that is the human body. You're well on your way to success. Don't forget to grab those free practice questions from the link in the description. With the depth of knowledge you gained today, plus the practice from those questions, you'll be incredibly well prepared for your OA exam. You've got this. Good luck.